Okay, so now that we've reviewed our exponent rules, we're going to talk about working with numbers in scientific notation. All right, so scientific notation is going to have a numerical value, we'll call it A, and A always has to stay between 1 and 10, but it can't be 10. It's actually got to stay less than 10. All right, so a number between 1 and 10, but less than 10. And then it's going to be multiplied by a value of 10 raised to a power that we'll call R. Because when you have 10 to a power, all that does is move the exponent, right? If the exponent is negative, it doesn't move the exponent, it moves the decimal. If the exponent is negative, it moves the decimal to the left. If the exponent is positive, it moves the decimal to the right. All right, so you'll see our steps here. To write a number in scientific notation, the first thing we're going to do is we're going to move the decimal so that there is exactly one non-zero digit to the left of the decimal point. Okay, so let's go ahead and do this in our first example. Okay, so right here in part A, I'm looking at 5,800,000. Okay, and right now the decimal is here because this is a whole number. So what I'm going to do is I'm going to move that decimal all the way back to here where there is one non-zero digit to its left, and that's the 5. Okay, so that means the first part of this, my numerical value, my A, is going to be 5.8. All right, and then it's always going to be times 10 to a power. So the second part is to figure out what that power is going to be. All right, so notice our rule here. If the decimal point was moved to the left, which is what we did, the exponent is just going to equal the number of places the decimal was moved. If the decimal was moved to the right, then the exponent will be the number of places it was moved, but it will be negative. Okay, so I look back here at mine. The decimal was moved to the left, and the number of places, 1, 2, 3, 4, 5, 6. So 6 places to the left means the exponent on the 10 will just be 6. And notice you can check that because 10 to the 6th power, that just means to get back to the original number, you would move the decimal 6 places to the right, and you'd be right back at your initial value. All right, so with big numbers, your exponent in scientific notation is going to be positive. With small numbers, like this one down here in part D, your exponent is going to be negative, okay? But the same process. So again, what I would do is I would look at my number. I would move the decimal until there is one non-zero digit to its left. So that's going to go right here. All right, one non-zero digit to its left, and that's a 1. So that means the first part of this is going to be 1.1 times 10. And then when I look at what I did with that decimal, okay, I moved it to the right. And when you move the decimal to the right, your exponent's always going to be negative. And the number of places is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 places, and because it was moved to the right, all right, also just a little hint here, because it's a small number, the exponent will be negative in that scientific notation. Okay, so again, a couple other examples that you can try, and then check with your completed notes. All right, so now we just want to make sure that we can go from scientific notation back to standard form. All right, and this one to me is even a little bit more straightforward, because when you're going back to standard form, the exponent just tells you how to move, right? If the exponent is positive, you move the decimal to the right. If the exponent is negative, you move the decimal to the left, and that's all there is to it. right? So like here is a positive exponent. So we're looking at 1.4. Exponent is positive, so I'm going to move the decimal to the right, and I'm going to do that 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. Decimal's going to go right here, and any empty spots are simply going to be filled in with zeros. So the standard form of 1.4 times 10 to the 8th power is going to be 140 million. All right, if the exponent is negative, then we're just going to go the opposite direction. We're just going to go to the left, right? So this one is 1.35, but the exponent is a negative 3. So we're going to take this decimal, we're going to go 1, 2, 3 places to the left because it's negative. And then again, you always just fill in any empty spaces with zeros. So in standard form here, 1.35 times 10 to the negative 3. In standard form is 0.00135. All right, so you might want to pause the video here at this point if you want to go in and just do some practice with just putting numbers in scientific notation and taking them out, right? Just to make sure that you get that down. But then the last thing that you're going to be doing in section 5.6 is just using, now we're going to kind of combine things together, using exponent rules to multiply or divide with values that are in scientific notation. All right, and all you have to remember here is that you can break this up into 2 pieces, all right? So notice these are being multiplied. And because each number is in scientific notation, you can multiply the numerical part, right? That'd be 3.4 times 2, or 6.8. And then you can separately multiply the powers of 10. And you just remember there that your exponent rules tell you when you multiply with exponents, you add the exponents together. All right, so again, this part right here just comes from me multiplying the numerical parts. And then with the exponents on 10, when I multiply, I add those together. And so in scientific notation, this is going to be 6.8 times 10. And 9 plus negative 5, opposite signs, so you subtract them. The bigger number than 9 is positive, and so the exponent will be positive here as well. All right, so this next one will work just the same. I'll leave that one for you. With division, you just want to remember that you're going to be subtracting your exponent. So once again, you can start with just the numerical part, 8.4. This one's division, so divide it by 4. That's going to give me 2.1. And then the 10, right, we're dividing, so we subtract the exponents. So we're going to take negative 7. Careful with your signs, you're going to be subtracting a negative 4. All right, so with subtraction, you know, you end up adding the opposite. 2 negatives make a positive. And so this is going to end up being 2.1 times 10. And the power here, since this is negative 7 plus 4, would be negative 3. Now, I am going to give you a little heads up here. Be careful when you go to enter your answers in MyLab. Sometimes it will ask you to enter your answer in scientific notation, at which point you'd leave it like this. Sometimes it will ask you to enter in standard form, all right? But you know how to go between the 2 forms. So no matter which one you have, use the rules that we just defined, moving the decimal, and you can always take it from scientific notation to standard, or from standard to scientific notation. Also, one last note here, when you are entering an answer in scientific notation, MyLab is picky. Don't use an X. Make sure you go to your math palette, right? That little bar that shows up at the bottom of the question when you click in the answer box. Use that for the X, and then you can, of course, use it to get your exponent as well. All right, and that's all there is to it in section 5.6. So like always, I'll post the completed notes. You can check your answers on all the other examples and then get to work in your homework for section 5.6.